In fluid dynamics, we have learned about all those equations, that is Navier-Stokes equation, Reynolds transport theorem, as well as conservation of mass, energy and momentum. So let us apply all these equations to solve problems on bends. So let us consider a problem on bend over here. So the problem states that a 300 liters of water is flowing through a pipe diameter 350 mm and right angle bend to the horizontal plane. So there will be a pipe which will be at a right angle to the bend. Find the force acting on the pen if the pressure at the inlet and the outlet, that is P1 and P2, which is P1 and P2, which is given to us as 30 and 27 Newton per centimeter square. So the problem is straightforward over here. Let us get into it. So let us write down the data which we know over here. The first thing which they have given to us, that is the flow rate, that is 300 liters per second, that is 300 into 10 to power minus 3 meter cube per second. The second thing which they have given to us is diameter, that is 350 mm. So this is 350 into 10 to power minus 3 meters. So this is 0.35 meters. The third thing which they have given us, that is theta is equals to 90 degree, that is the angle of bend. And the two other things they have given to us, that is P1 and P2. According to the question, the value of P1 is 30 Newton per centimeter square and P2 is 27 Newton per centimeter square. Now 1 upon centimeter square is equals to 10 raised to 4 1 upon meter square. So this is quite straightforward because 1 meter is equals to 10 raised to 2 centimeter and 1 meter square will be equals to 10 raised to 4 centimeter square. So it all makes sense in this part if you take reciprocals. So you will get this part over here. So over here this will be equals to 30 into 10 to power 4 Newton per meter square. This is 27 into 10 to power 4 Newton per meter square. Now let us draw the diagram for this entire part. So this is bent by an angle of 90 degree. So now this will be an inlet and the outlet will be at an angle of 90 degree. Now it has an uniform diameter, so over here there is no difference in diameters. So this diameter is D1, this diameter is D2, but actually both the values are same. So at the inlet, let us consider this as section 1,1, this as section 2,2. The force acting or the pressure acting over here is P1. The force will be P1 into A1. The pressure acting at the outlet will be P2 and the force acting will be P2 into A2. Now this is flowing along horizontal direction with a velocity v1 and the outlet velocity, will consider this as v2. Now since the area of cross section over here is same, that is d1 is equals to d2, hence a1 will be equals to a2, then v1 will be equals to v2 according to the continuity equation. So now let us calculate value of v1 and v2. For that we'll calculate the value of a, that is pi by 4 into d square. So this is pi by 4 into 0.35 square, that is the diameter, which is uniform diameter, which is which is same throughout the pipe. So this is equals to 0.0962 meter square, and q, which is given to us as 0.3, and velocity v1 is equals to v2, that will be q upon area. So that will be equals to 0.3 upon, this is pi by 4 into d square. So this is 0.3 upon 0.0962. This will give us as 3.118 meter per second. So we have evaluated the velocities as well as we have calculated the area of cross section. Now we know the inlet pressure and the outlet pressure. So now we have calculated what is V1, V2, as well as we know the flow rate as well as density, and P1 and P2, that is pressure at the inlet and outlet, they have already given to us. Now let us draw the master diagram for this entire problem. So master diagram will consist of four things. First will be force, then it will be a velocity. Third thing will be inlet. Next thing will be outlet. So now let us write down the force. The force at the inlet is going towards right, that is P1 A1 according to our diagram. Let us see all the things which we know over here. So P1 A1 force at the inlet, P2 A2 which is going downwards, force at the outlet, V1 is going towards right at the inlet and V2 is going upwards at the outlet. So let us draw this. So at the outlet, this is coming down, this is P2 A2. The velocity at the inlet is horizontal, so this is V1, and the velocity at the outlet is V2. So we have drawn the entire diagram. This diagram is called as the master diagram. According to this vector diagram, we are going to apply equation of motion. So now let us apply equation of motion along x direction. Summation of fx is equals to rho into q, final velocity along x direction minus initial velocity along x direction. So now let us apply the equation along x direction. So this is fx plus, there is only one force which is acting along x direction, that is P1 A1, that is going towards right, and the velocity which is along horizontal direction, that is P1. So now let us write this part. So this is a P1 A1, this is equals to rho into q, the velocity along x direction, that is the velocity at the inlet. So the outlet velocity is 0, the inlet velocity is there, that is v1. So this will be 0 minus of v1, that is value v1. So let us evaluate this. So pressure was equals to 30 into 10 to power 4, area of cross section which we had calculated, that was 0.0962. This is 1000 into the 1000 into 0.3, that was the flow rate, into minus of V1. V1 we had calculated as equals to 3.118 meters per second. So all these values we had calculated. So we get on evaluation Fx is equals to minus 29.79 into 10 to power 3 newtons. Negative sign represents that it is acting in the opposite direction. So 29.79 kilonewton, it is acting towards left, not towards right. Next part, we'll apply the same equation along y direction. So this will give us summation of Fy is equals to, that is equals to m dot into Vy minus Uy. So this is force along y direction plus, from our master diagram we'll see there is only one force which is acting along y direction, which is this, and there is only velocity which is acting along y direction, that is v2. So this is minus of p2a2 is equals to rho into g into final velocity, that is v2 minus initial velocity, that is 0. So Fy on evaluation will get this as 29.909 kilonewton. So now let us calculate the resultant. Resultant will be square root of fx square plus fy square. Note that this will be positive, hence it is going upwards. So this will give us as 39.5 kilonewton. If we draw this, this will be towards left and this is going upwards. So the resultant force is acting in the second quadrant. So this part will be clockwise and that part will be negative. So that will be tan inverse of Fy upon Fx. So this will give us minus 40.4 degrees. Negative sign represents that it is in the clockwise direction from the horizontal axis. So now we have calculated what is Fx, Fy resultant and theta. I hope you have understood how to calculate the resultant force which is acting on a bend which is inclined at an angle of 90 degrees to the horizontal. Thank you.